Hi friends, in today's episode we will solve a very interesting and beautiful concept from quadratic equations. Now at the face of it, this question might look very scary with the words like biquadratic, degree to the power 4 and whatnot. But don't worry, if your concepts from ninth grade and 10th grade are strong and if you've understood the concept of multinomial theorem, this question should be a cakewalk. Before I show the solution to the question, I would like you to pause the video when I display the question, attempt it with the confidence and belief that you will be able to do it. And if you are not able to do it, don't worry, go through the solution and understand what you've learned from the solution. Alright, moving on to the question. Alright, hope that you have given a fair shot to the question. Now for the solution. Let's look at the first part of the question, which says that f of x is x square plus ax plus b has one of the roots as 4 plus 3 root 3 by 2 plus root 3. Now, one very interesting thing we had learned when we were learning irrational numbers in ninth grade is irrational numbers in the denominator is something that is not great. So the first thing that I will do is rationalize the denominator. For me to rationalize the denominator, I just need to multiply this with its conjugate, which will translate to 2 root 3 minus 1 by 2 square minus root 3 square, which is 2 root 3 minus 1. Great. So this is the first step. If you look at it, you will realize that one of the roots that is available here is in fact an irrational number. However, it is said that both a and b are integers. And we know that a rational number cannot be added to an irrational number. So what does it leave us with? If one root of the equation f of x is 2 root 3 minus 1, by extension, the other root has to be minus 2 root 3 minus 1 because the product of both the roots, alpha beta, is equal to b, which is an integer. Alpha plus beta is equal to minus a, which is also an integer. And if the roots are not conjugate of each other, this will not work out. Which brings us to the first part of the solution. A is equal to 2 and b is equal to 1 plus 12 minus 11. So far, any doubts? All right. So this brings us to the fact that f of x is in fact x square plus 2x minus 11. That f of x is x square plus 2x minus 11. We need to find the value of g of 4 plus 3 root 3 by 2 plus root 3, which is g of 2 root 3 minus 1, where g of x is x power 4 plus 2x cube minus 10x square plus 4x minus 10. Now, there was a very interesting concept in ninth grade called remainder theorem and factor theorem. Just to revise that concept, the remainder theorem stated that if g of x is divided by x minus alpha, g of alpha gives the remainder in this case. And by extension, if remainder is 0, then by factor theorem, x minus alpha is a factor of g of x. So it's like dividing this equation g of x by x minus 2 root 3 minus 1. However, if you notice, f of x has one of the roots as 2 root 3 minus 1, which was given to us. So is it possible for me to write g of x is equal to f of x into some other function p of x plus r of x? And when I substitute x is equal to 2 root 3 minus 1, this part will become 0 and g of 2 root 3 minus 1 will be equal to r of 2 root 3 minus 1. In fact, what we have done is we have simplified a complex biquadratic equation into a simple linear equation, finding the value of 2 root 3 minus 1. Now, it is very easy to do this, which I will present to you in the next slide. All right, folks. Now that since we have identified g of 4 plus 3 root 3 by 2 plus root 3 by remainder theorem will be the value when substituted, and by long division of polynomials, if we divide g of x by f of x, we will get quotient as x square plus 1 and remainder as 2x minus 1. We can write g of x as f of x into x square plus 1 plus 2x plus 1, which is the remainder. And by remainder theorem, g of 4 plus 3 root 3 by 2 plus root 3 is g of 2 root 3 minus 1, which is equal to 2 into 2 root 3 minus 1 plus 1, which is 4 root 3 minus 1, which when compared with c root 3 plus d, c is 4 and d is minus 1. Those are the answers. We have got a as 2, b as minus 11, c as 4, and d as minus 1. I'm just going to summarize what concepts we have used in this. We have first used the concept that since sum of roots and product of the roots are rational numbers, and one of the roots of a quadratic equation is irrational, the other root has to be the conjugate or the rationalizing factor of the root. The second theorem that we have used, which we have learned in our 9th grade, is if a polynomial f of x is divided by x minus alpha, the remainder is f of alpha. And we used long division method to find what is the remainder polynomial when g of x is divided by f of x. Instead of substituting the value of 4 plus 3 root 3 by 2 plus root 3 in g of x, we actually substituted it in the polynomial of remainder, which was in fact a linear polynomial. Just summarizing, sum of roots is integer, remainder theorem and the remainder by long division. Honestly, to solve this complex question, these are the only topics that were needed. I hope you found this solution useful and exciting. If you did, like, subscribe, and share, and do recommend our channel to your friends and family. All right, see you for our next episode.